news lately and you've seen some of the numbers of virus infections, you might have seen numbers around 6,000, 8,000, a little over 10,000, which in a country of 300 million people might make you think, hey, that's not that much. What is everybody so worried about? How is that possibly going to overwhelm the hospital systems? Why are we so worried? And I think that a lot of that has to do, and a reason that it can be hard to understand is because if you're somebody like me and you haven't done much math or science really since high school, it's hard to really picture the way that viruses grow. A lot of us in our heads have a model where, this person infects this person and they infect somebody. It's kind of like a trail of sick people. And I've seen some videos that kind of use this model. So the most popular one I think I saw was there was a train of matches, and it kind of was, well, this match is on fire, and it lights this match on fire, and it lights this match on fire, and it lights this match on fire, and it's about to light the next one on fire, but this person steps out of the way, and so, or sorry, this match steps out of the way, and so this one doesn't catch on fire, and so this person is safe, and all the people afterwards are safe. So the fire basically stops here, and I get what they were trying to do. It was supposed to be about social distancing, and I think it was a good illustration of how you can prevent the spread of a virus. But I think one downside of that video was that it still used this model of kind of a line where one person infects the next person and they infect one person after them. And that's kind of what you would call a linear model. The reality of how viruses spread is more of what we would refer to as an exponential model, where each person infects multiple people. And what I thought I would do is kind of show visually what the difference is between the two. So, just quickly, instead of infecting one person, this first person infects multiple people. So I want to do a comparison of the two and show how different they are and why it might be hard to sort of wrap your intuition around why this could get out of hand so quickly. So as I was saying before, in the kind of line model, this person infects this person, and this person infects that person, and this person infects that person, and this person infects that person. So I went 4 steps. So we go 1, 2, 3, 4. So let's say this is happening over here, and this person is about to infect another person, but actually they're really good about social distancing and staying inside. And so these 3 people don't catch the virus. And that seems well and good, and it's good for these 3 people. But you kind of would wonder, how is this kind of trend, if I have a couple people stay inside and block off the train, how's that really going to help a hospital not get overwhelmed? So, why am I staying inside? But again, this is actually not an accurate model of how viruses spread in the real world. So instead, I'm going to do this exponential model, and you'll see very quickly how much longer it takes me just to simulate it. So in this model, this first person infects 3 people, and now each of them infects 3 people. So this guy infected all of these people. Oops. Okay, I think I need one more. Yep. Okay, so these 3 are from him, these 3 are from her, and these 3, oh, am I missing one? Need one more. Okay. Now you can already see in just 2 steps how much this is kind of blown up by comparison. Here, in 2 steps, we had 3 people total. Here in 2 steps, we have 14 people already. And I'm going to do one more step, and then you're going to see after that I'm going to actually start to run out of room. I won't be able to draw it on the page. But you'll see how quickly this starts to get out of hand. So 3 for this person. I'll shift these over a little bit just to make some room. And 3 from this person. And 3 from this person. Let's see, where am I? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. This isn't even half of the people I need for this step. So I still need 10 more. Count one more time. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Now, I just want to emphasize again, this was 1 step, 2 steps. This was the 3rd step, where there were 3 for each of these people. This was the 3rd step in a linear model. This is the 3rd step in an exponential model. I can't even go up to the 4th step. I would have to get 81 of these in this space here, which they are just not going to fit. So after that, if I did the next step, it would be 81. And the next step after that would be 243, I believe. And one more step would be 600 people. At that point, an infection that started with this one person has gone to about 1,000 people. And that may seem kind of crazy. It's really hard to kind of wrap our heads around that. And you may think there's no way this one person can cause 1,000 infections. But actually, that happened in real life. There was a South Korean patient who ultimately, over 1,000 infections could be traced back to that patient. And so you can see now, just imagine this keeps going and going and going. Alternatively, maybe this kind of started here, and these 2 people stayed indoors or stayed away from people, and this person stopped going out. And you can see how all of this that's just starting to get out of hand, this process can stop. And that's really what we're trying to accomplish to help the medical system. We're trying to prevent this sort of explosion in cases that will overwhelm doctors, nurses, and other medical staff. So thanks for watching this. I appreciate your time.